Greetings, everyone. I wanted to create another video of a problem from our book, of the solution to the problem I come from our book, section 2.5, number 47. And I'll read the question in just a moment. I like this question because it has, as you see from this equation here, a lot of variables in it. Rather, a lot of letters in it. Some are variable, some are constant. But these typically are intimidating to students who are just learning calculus. And I want to go through a problem like this because although it may be intimidating, we need to get beyond our fears and be able to handle things like this because it's really not that bad. And if you're following what we've been doing in class well and you're getting the practice that you should be getting, you should be able to handle a problem like this without too much stress. Alright, so the problem is, again, number 47, and it reads like this. The van der Waals equation for n moles of a gas is, that's that equation right there, where P is the pressure, V is the volume, and T is the temperature of the gas. The constant R is the universal gas constant, and A and B are positive constants that are characteristic of a particular gas. Alright, so right from the start, they're telling us A, B, R, and R are constants. And N is a constant as well because it represents just some number of moles of gas. What this equation does is it represents the relationship between pressure, volume, and temperature, changing quantities of a gas. For instance, if we alter the temperature of this gas, then we'll have a corresponding change in volume and a corresponding change in pressure to make this whole equation remain true. Similarly, if I change the pressure, then I'll get a change in volume and a change in temperature that will correspond to whatever makes this equation true. Lastly, if I change the volume, then the pressure and the temperature will change in order to make this equation true. Now the question here, or the statement of the problem here, is if T remains constant, use implicit differentiation to find dV dP. So even beyond N, A, B, and R being constant, we're going to have T be constant in this problem also. So we're going to try and hold our gas at a constant temperature. So the problem is asking us to find the derivative of the volume with respect to the pressure. The instantaneous rate of change of the volume with respect to the pressure. This is what we're trying to find. Now, in terms of what we've been doing in class, this actually is like trying to find V prime, okay? In other words, in class we've been doing a lot of finding dy dx, and V corresponds to y, P corresponds to x, but I'm not going to make that change, nor should you. You should keep, in terms of the original variables, and be able to handle them, okay? But essentially we're just trying to find V prime. Let's go back real quick. We said a bunch of things were constant, so let's list those so that we keep track in doing the calculus here of what's constant. So these are our constants. We said N was a constant, represents how much gas we have, the number of moles. A and B are positive constants. Depending on the gas that we have, they have different values for A and B. R is the universal gas constant, and capital T is going to be constant in this problem here. Generally speaking, it's not as mentioned before. Alright, so we're going to differentiate with respect to P. Let's get started. Alright, so I'm going to use a differential operator, d dp, of the whole left-hand side. Now again, notice I'm not writing dv dp here because I don't have the derivative of v at the moment here. Okay, this is saying to take the derivative with respect to p of the volume. Okay, so I need to take the derivative with respect to p of the left-hand side, and in that work, I'm going to end up with a dv dp or a v prime in the process. So right now, I'm just going to copy what we have up there, like this, and if we differentiate one side with respect to p, in order to balance this equation, I need to differentiate the other side with respect to p. The nice thing about the right-hand side, as we mentioned before, all of those terms or factors are constants. And since all those factors are constants, the derivative of a constant is going to be 0, and so the right-hand side works out very nicely. The left-hand side is going to require several of our differentiation rules, or theorems, or simplification, or shortcuts rather, to take the derivative. For instance, I got a product, so I'm going to apply the product rule, derivative of the first factor times the second factor, plus derivative of the second factor times the first factor. And then inside, I'm going to have to take derivatives as well. One thing I'm going to do is I want to think about one particular piece, this piece right here, differently than how it's written right at this moment. If I look at it this way and I take the derivative, I might think that I need to apply the quotient rule, and the quotient rule would work, but I try to avoid the quotient rule when possible. So I'm going to rewrite this with a negative exponent so that I can apply the general power rule along with the constant multiple rule in order to take the derivative. So this is how I'm going to think of that term when I take the derivative. Alright, so let's get on with this. I'm going to go on to the next page and take the derivative on that page rather than try to squeeze it at the bottom of that one. Alright, so the derivative of the first term. The first term had a p in it, or the first factor. Derivative of p with respect to p is just 1. That should be pretty straightforward. And then we have to add to that the derivative of the second factor. That was that n squared a times v to the negative 2. So you need to go back and look at it, rewind the video a little bit, and you can see what we're talking about. So the minus 2, or the negative 2 is going to come down as a multiplier. N squared a, constant multiple rule, times v to the negative 3. I have to subtract 1 from the negative 2. Also, remember, I'm differentiating with respect to p. P is different than v, so this is a point where we need to emphasize the or utilize the chain rule and take the derivative of the inner function, which is going to be v prime. Or dvdp, which I don't feel like writing the whole dvdp. So that's the derivative of the first factor times the second factor, which is just v minus nb. And there's the first part of the product rule, plus the derivative of the second factor. Here's the second factor. I need to take its derivative. N and b are constants. The derivative of a constant is 0, so that part's going to become 0. And the derivative of v with respect to p is just going to be v prime. So the derivative of the second factor is just v prime times the first factor in the product rule. The first factor had p, and then we had plus, and I'm going to use the rewritten form n squared a v to the power of negative 2 to complete that. And then that's going to equal the derivative of the right-hand side, which is going to be 0. Now we're solving for v prime, and so I have v prime in several different places here, so I'm going to have to do a little bit of algebra to get all the v primes spread out everywhere, collect them, factor, move all the non-v primes to the other side. This is stuff that we've been doing in some recent homework problems. So I'm going to FOIL this out. In other words, I'm going to distribute this difference here to this difference over here. I'm going to distribute that 1. 1 times v is v. 1 times nb is nb, so v minus nb. Then I got to distribute all of this to this, and I got to be careful. Most of this stuff is going to stay the same, but I'm multiplying by v, and since I have a factor of v here to the power of negative 3, I'm going to add their exponents and get a factor of v to the power of negative 2. So I have a minus 2n squared a times v to the power of negative 2, and don't forget your v prime. Now I got to distribute this second term to the second term over here. The negative times the negative is going to become a plus. The 2 is still there. I'm going to have an n cubed for the n squared times the n. I'm going to have the factor of a. I'm going to have the factor of b. So I'm going to have the factor of v to the power of negative 3 times v prime. Okay, don't want to forget that. A little bit more. I hope I can squeeze it in here. I'm going to have p times v prime. When I distribute the v prime here, plus n squared a v to the negative 2 times v prime. And we just squeeze it in there equal to 0. Okay, so I have a bunch of terms with v prime. I have 2 terms without. So I'm actually just going to move those over there right now. Those terms without v prime go to the other side. They become opposites, so I can just reverse the order of the subtraction, get the opposite. That's on the other side. Now for what's left on this side, Notice that I got a negative 2 n squared a v to the power of negative 2 over here, this factor, or this term. And then I got another term way over here which has all the same factors in it except for the constant factor right here. But since they're like terms, I can now combine them in my work over here to simplify this. But remember, I'm trying to factor out v prime, so I'm going to do that. I'm going to combine the algebraic steps. I'm going to have a v prime. What's left? The combination of those, but that's going to be negative, so I'll deal with that last. Let's factor the v prime out of here first. I'll have a p. Factor the v prime out of here. I'll have a 2 n cubed ab v to the power of negative 3. And then when I combine those two, I get a negative 1 n squared a v to the power of negative 2. So I'll have a minus n squared a v to the power of negative 2. And that's what I have left over here. So now solving for v prime, just through some division, we're going to get nb minus v divided by all of this stuff that we have right over here. And so, just write it down, n plus 2n cubed ab v to the power of negative 3 minus n squared a v to the power of negative 2. Now your answer in the back of the book, since this is problem number 47, will look a bit different than this. Alright? And what they do is they get rid of these negative exponents here, which is a common form people like to write in mathematics. But not necessary, but just so you know where the form that they got came from. The largest in magnitude negative exponent I have is negative 3, so to clear everything off, I can multiply the numerator and denominator by v cubed over v cubed. Here, let me change this to parentheses. So we get v prime equal to v cubed times nb minus v over, when I distribute the v cubed down here, I'm going to have a pv cubed. The v cubed times the v to the negative 3 cancel. That was the purpose of that term. So then I'll have a plus 2 n cubed ab. And then when I multiply this, the v to the power of negative 2 times v cubed, add those exponents, I'll just get a single factor of v. I'll have a minus n squared a v. And we have our v prime. Now this was only part A of the problem. For part B of the problem, we were given some particular values to which to calculate v prime. For part B, it says find the rate of change of the volume with respect to pressure, dVdP, or v prime, of the gas, of 1 mole of carbon dioxide. So 1 mole tells me that the value of N is going to be 1. It says, so 1 mole of volume, 1 mole of carbon dioxide at a volume of 10 liters, V equals 10 liters. And pressure, P equals 2.5 atmospheres, ATMs. That's just the unit of measure for pressure. And then they give us some values for A and B. I'm not going to fit the units for A and B in here because it's just going to take up a lot of space. But they tell us that A is 3.592 liter squared atmospheres per mole squared. It's a bit of an odd unit, but it makes things work. We'll talk to your chemistry or physics teacher about why that is. And then B is 0.04267. Whoa. Whoops, hit a button. 0.0. Took me a moment to get this corrected there, but I got it. 0.04267. Alright. So, to do part B, which I'm not going to do for you, the answer is in the back of the book. Plug 1 for N, plug, that says 10 liters, plug 10 in for V, 2.5 in for P, these values in for A and B, do the calculation and see that you get the answer in the back of the book. At some point, you should probably go back and try to redo all this, all the derivative stuff up here on your own, and see if you can come up with the correct answer without watching the video or looking at your notes.